of nanocomposite with, different techniques and their properties, comparison of their different properties. Okay. So this work is basically deals with preparation of polymer nanomaterial based nanocomposite. And then we have studied the mechanical properties and some biological characteristics like osteoconductivity or biomineralization and biocompatibility with Mg63 based osteoblasts. Okay. The application was we have focused on bone tissue regeneration. Okay. So the matrix was polycarbonate based polyurethane. It's a kind of copolymer, and the filler was, the filler means nanomaterial was hydroxyapatite. Okay. So here you can see that filler is also like kind of polymer wrapped hydroxyapatite nanocomposite. That means the filler was modified by using kind of some polymers. Okay, that is what we have written polymer wrapped hydroxyapatite. So does anyone know the how this modification is works and all, like usually why the people used to modify the surface of nanoparticles? Because if we see the charges on the surface of nanoparticle, like they are negatively charged, of course, and they belongs to polar. Total overall they consider as a polar groups. Okay, if we see the polymer-based matrix, okay, they are basically non-polar, like because they are combination of mostly of carbon and hydrogen. So if you want to mix this polar and non-polar, they cannot mix. They won't at all. So if you want to mix it well, incorporate it well into the matrix, you have to modify the surface of the nanoparticles with the help of any surfactant. The surfactant you have polar groups and non-polar groups. Okay, it's a kind of miser life. So basically, the OH, negatively charged species on the surface of a nanoparticle, they will start to react with the, surfactant of your, polar, non-polar regions, and then they will end up with the non-polar, shell of your nanoparticle. That means your nanoparticle surface has been completely modified by the surfactant. Okay. So once the surface become non-polar, then it will be very easy to get interact with this kind of polymer-based matrix. So yeah, now you're gonna see there are different stories like without modification and by preparing the composite, how the properties. And with the help of polymer-based modification of nanomaterials, and thereafter mixing of those modified nanomaterials into the polyurethane matrix, and how the properties are. You'll see. Sorry. Yeah. So I'll upload this paper. You can have a look, and nevertheless, you just read out this abstract. The present investigation reports the preparation of two types of 2D rod-like nanohydroxyapatite nanomaterial, and one is unmodified one, and another one is polypropylene glycol wrapped one or modified one, and having various aspect ratios, and which are prepared by modified co-precipitation method, and without any templates. This nano hydroxyapatite rods were successfully introduced into novel synthesized thermoplastic polyurethane matrices based on polycarbonate subsegment, and which was prepared by using both in situ as well as ex situ method. In situ means, we have seen it, and ex situ means just solution casting. Okay? Solution casting is also been called as ex situ techniques for the preparation of nanocomposites. And then, yeah, physical mechanical properties of the prepared, sorry, yeah, physical mechanical properties of the prepared nanocomposite studied, and it shows in situ prepared one shows a superior one compared to the of ex situ counterparts, as well as compared to the of pristine polyurethane matrix. And then likewise, then we have seen the improved biocompatibility as well as osteoconductivity for the prepared nanocomposite. And yeah, these are different assays. MPT assay basically, where we used to study the how much the cells are viable and how much cells are dead actually over a period of time. When the moment you are taking your materials into the cell culture dish. And then we have seen how good the biomineralization or the osteoconductivity with the help of SBF buffer solutions. And then we also have seen blood compatibility of the prepared nanocomposites. Okay. So finally, we have derived some of the thermodynamical, aspect like interfacial adhesion parameter in the sense like how polymer filler affinity is happening for different fillers or different nanocomposite prepare. All right. So now you can have a look like how the materials were prepared, like a headache separate, what are the precursors, how the rana composite was prepared. I'll upload this paper and then you just read out these stuffs. Okay. Now straight away I'll get into the properties. Structure property relations. Okay. So this is some of the transmission electron microscopes. So the prepared nanomaterials. You can see here one is unmodified one and one is modified one. You can see here unmodified one. There are, you can see only the nano rod, which has which the surface is free of any kind of groups. And in case of modified one, you can see you have a height accepted, and on top of that, on the surface is, covered by some of the polymers. Even the density is very less. That's the reason the electrons easily penetrate into that organic portion. Okay, during the transmission electron testing, instrument testing. So you can see here the polypropylene critical layer as well clearly. So this is how the scheme shows like how it was wrapped on the surface of a hydroxide nanorod. Okay. And yeah, we have studied the FTER and wide angle X-ray diffractions of the prepared nanohydroxide particles. Modified, unmodified one. So any idea how to use FTER and XRD of this prepared nanocrystal? Because once you modify the crystals, the bulk properties should not change actually. Okay, only the surface should be modified. Okay, they should not alter the crystal structure of the prepared hydroxide crystal. That's the reason we used to study the wide angle X-ray diffraction, like before modification and after modification. Is there any changes in the, either crystallite size or kind of any stress inducement or kind of thermal transition, etc. So it shows that there was no clear, shifting of those peaks or peak broadening, etc. That shows the crystal structure retains the same. And FTR again, it shows the functional group presence in your materials. Okay, like after modification, you can also see some of the organic groups like a CS2 stretching or like kind of structural overage, as well as some symmetric and asymmetric deformation, etc. So which confirms the presence of your organic groups on the surface of your nanomaterials. Fine. So just read out. A lot of chemistry is involved, like how the van der Waals force is helping for grabbing those kind of uh, PPG molecules, and as a result, once the charges gets equalated, like then the nucleations will be pushed towards to that for certain direction. As a result, the nanorod, the aspect ratio will be increased. So NMR also kind of spectroscopy studies where we can study the quantitative as well as the qualitative analysis of your proton presence in your polymer backbone. Okay, because this was tailor-made polyurethane, that means we have synthesized in our lab. So you can see here like a proton NMR, like how many protons are present in each carbon can be analyzed. Okay, and for this kind of qualitative analysis for the carbon NMR. Okay, so we have a different carbon in presence in your polymer backbone. So if you apply the magnetic field, they behave for different spin microscopy. And according to that literature, as well as there are a lot of empirical equations where you can fit your carbons, peaks according to that position. That is belongs to the qualitative analysis. So this was the filler dispersion. Like once you have prepared the nanocomposite, again you can see how the particles are dispersed on the surface of your matrix. So this one was prepared by using ex situ technique, like eTPU NPM means ex situ prepared nanocomposite, and ITPU PPG or nano NHA means like kind of in situ prepared nanocomposites. Okay. And yeah, so you can see here the ex situ prepared one slightly having sort of aggregate structures. But in case of in situ prepared composite, you can see here the filler dispersion is pretty good actually. And in fact, the nanoparticle size was also retained. But in case here, you can see here like there are some of the nanoparticles got broken or their surface got, defect, kind of some distortion happened. So all these things happen in the in situ composite and ex situ composite prepared one, and the in situ one shows very good morphology. Well, and then yeah, you can also see some of the spectroscopy FTR where is there any hydrogen bond formation or something. If there is hydrogen bond, some bond formation was happening, then you can also see some of the functional groups shifting towards to the lower number in the FTR. So now coming to the main picture, the physical mechanical properties of the prepared composite. This is a stressing graph of the prepared nanocomposites of various sample, and this is pure TPU, and the red one is belongs to ex situ prepared composite of pure, nano heteroseparate material. I mean unmodified filler. Again, you can see here the green one belongs to the ex situ again, but which is slightly modified by using PPG based propylene type. And last to these two belongs to the in situ prepared one, and this is belongs to the in situ PPG one. I mean the modified one, and this one belongs to the unmodified filler, but which was prepared by using in situ polyurethane based matrix. You can see here the pure TP, of course, they have got a very less tensile strength as well as the elongation. But in case of, composite, like the moment when they add the filler, you can see the improvement in the mechanical properties like a tensile strength as well as the elongation was also increasing. But the thing is that in situ prepared composite, of course, they are pretty high strength compared to that of in situ as well as the pure polyurethane. But yeah, the in situ prepared one, the PPG, the modified filler reinforced composite is showing very less strength, but the unmodified one is giving a better mechanical properties. So why is it? Because there are a lot of factors during the in situ polymerization usually happens. If you see the surface functionality of unmodified filler, the nano hydroxide based filler, they've got a large number of OH functional group. But in case of once the modified filler, if you see the number of functional group OH group presses on the surface of the filler, they've got a very less OH functional group. Okay, so in the polyurethane chemistry, actually the OH is having high, feasibility to react with the isocyanate-based hot segments. Okay, so once the fillers start to react chemically with the polygon matrix, what will happen? They will have a more interactions. Although PPG is modified, but since they have less sort of like a shortening of this OH functionality, so as a result, they cannot react chemically with the polyurethane matrix. So that's the reason why the unmodified one still gives better one that of modified filler. But in case of exit, you can see the modified filler is dominating than that of the unmodified filler one. Okay. So this is one of the few observation of this structure property relationships. So which was reflected in this the shifting of those peaks, like hydrogen bond interaction, how much exactly the hydrogen bond formation, and their quantitative determination, like how much delta H energy was, which was obtained for different nanocomposites. So for your information, please read this paper, and your exams will be like this kind of question. I don't ask you the direct questions, okay? So please, have a look, and even if you have doubt, we can discuss still further. Like, so start to read today this article. But of course, I don't ask you the other things like biocompatibility or cell differentiation because you have not studied. I know that. So, but still, like you can read some of the stuffs like how the energy was calculated of something like a delta H or kind of some peak position was changing. Why is it so? Okay. And yeah, of course, the physical mechanical properties like tensile properties easily you can interpret. And this is some of the other characterization or the property evaluation, something like biomineralization or osteochondrial, because our application was bone tissue regeneration. So we have to test it with some buffer solution where they can induce some minerals or mineral deposition. So once you immerse our scaffold or the Phillips which was prepared, and then you can see how much the surface is getting changed actually. So you can see here some of the crystals formation on the surface of the prepared composite. That is nothing but calcium and phosphate. So that means that our composite sample is inducing some sort of mineral formation, where it can be used for bone implants, etc. So this is some quantitative determination of how much the cells which was proliferated over the period of time. You can see here from the day 1 to day 7, the cells, yeah, getting pretty much high, and they're getting interacting well with the matrix. Yeah, so this is some of the macroscopic structure of the prepared cells. Of cell culture results. Like you can see here, once the days goes 7, you can see how much the cells which are, proliferated on the surface of the samples. Yeah. So did you understand something from this paper? What is a structure property determination or studies something? All right. So today we will start something different stuffs. Yeah. So all we have seen the nanocomposite preparation and the different melt mixing chambers like injection molding, extrusion, as well as blow molding, etc., compression molding. So today we'll get into the fabrication technology of something called fiber reinforced plastics or FRP composites. Okay. So FRB, they are nothing but fibers will be used as a reinforcement or reinforcing phase. Okay? And most of the common fiber materials are like glass, carbon, and Kevlar based material. Kevlar is nothing but what? It's a kind of nylon based polymers. Okay. And in some of the fabrication process, the filaments are continuous. That means the fibers are continuously used to get, uh, reinforced with the matrix. And sometimes they used to chop it with the help of different, saws to have the very short length and where you can reinforce it effectively. And in the continuous form filaments, the individual filaments are usually available as a rovings. Rovings means it's a collection of, untwisted continuous fibers or the strands. Okay. And yarn means the twisted collection of filaments. Okay, that means just like one, nylon thread, what we are getting from the market. Okay, that is called yarn. That means one yarn has, it's a continuous or more amount of fibers in the form of twisted version. Okay, and rovings means it's a collection of untwisted, continuous strands of the fibers. The very simple example, the most similar form of continuous fiber is a cloth actually. The fabric of woven yarns, if you see your, your cloth or any kind of this one, what we are using in the day-to-day life, you can see the one thread actually, and they are twisted of a lot of fibers actually. That is called yarns. And similar to the cloth is woven roving and fabric consisting of untwisted filaments rather than, yarns. So likewise, people use different types of fibers or the, kind of filaments for the preparation of fiber reinforced composite. Okay, and then their direction of reinforcement and how the alignment, like kind of unidirectional or bidirectional, or what kind of angle they are keeping during the reinforcement. All these things will be very important. Where you want to have those desired properties of the prepared fiber reinforced plastics composites. So as I said, the fiber can also be in the matte form. Okay, sometimes what they do, like they used to prepare the fibers. Using some glue and all, polymer based glue. And where if you want to prepare the sandwich structure or some sort of like kind of multi-layer structure based composite. Okay, in that case, like one layer will be acting as a matrix. That means plastics resins, and the next layer will be used as a fiber, which was neatly constructed using the help of one polymer-based glue or the binder. Okay, where the fibers are randomly oriented and loosely together, bonded with the help of polymer-based binders. And yeah, sometimes they use some sort of cross linker or thickener, etc., where they can enhance their viscosity and you can tailor make the properties like strength of the matrix. So yeah, combining matrix and reinforcement, that is called, fiber reinforced plastics. Okay. And we have a different fabrication methods to have those kind of structures. Okay. And resins usually act as a matrix, and fibers will be acting as a dispersed phase. Okay. And similar to that that we are using in the plastics mold, just like compression or the injection mold. But yeah, the few things are different for making FRB based plastics. We'll stop here. We'll continue from the next class, like what is pre-bake, etc. So, as of now, any question now on this paper or kind of FRB? Of course, FRB I didn't go still the topic, fabrication methods. So I'll upload this paper. You please try to read, and yeah, it takes some time for you, but still you try to read, and if you have doubt, we'll discuss further. You try to get all this thing, like what is the, like how the free energy is calculated, and once the free energy calculated, how the delta H is calculated for the particular composite. And the tables, that's what I given the table here. Okay. Okay, if there is no question, we'll sign off and see you in the next class.